So previously, when we looked at compound interest, we saw that the more often we compound the interest, the more interest we get. So if it's the Renaissance and we have fancy new decimal arithmetic, we probably don't want to compound too many times because we're working out all the math by hand. But if it's the 21st century and we have a calculator, we can compound as often as we want. Does that mean that we can get as much money as we want by compounding more and more often? Let's see what happens when we compound this loan more and more often. So this loan is $5,000 at 5% interest for 10 years. I'm going to do a little bit of calculator trickery to prevent having to enter this expression over and over again. I'm going to take 1, my first frequency, and store it in x. And then I'm going to have 5,000 times 1 plus 0.05 over x to the power x times 10. And now whatever value I have stored in x is going to be plugged in the place of my 1 here. When we compound once a year, we end up with, I'm going to round to the nearest cent because we're talking about money. We end up with $8,144.47. Okay, what if we compound quarterly? I'm going to store 4 in my x, and then I'm going to go up and grab that expression again. Okay, if we compound quarterly, that goes up to $8,218.10. So that was a pretty good gain, almost $100. What if we go up to monthly? Well, okay, that wasn't as good, right? Now we've got 8,235 and 5 cents. That was what's like $17. Okay, what if we go up to weekly? And we'll be finance people here. We'll pretend that there are 52 weeks in a year instead of 52 and a bit. Okay, well that still went up, but hardly by anything, right? Now we've got 8,241.63. So that was like $6. Daily, again, we'll be finance people and we'll pretend that there are 360 days in a year. Oh, that got us like $2 extra. 82.43.32. What about hourly? And here we're still pretending that there are 360 days in a year, but we're using that there are 24 hours in a day. So 86.40 we get 82.43.59. Okay, that only gained us a few cents. Right, let's just try a big number for the sake of argument. Right, let's say we compound 10,000 times in a year. Now that's not that much more than 8,000. How about 100,000? That got us 2 cents when we round to the nearest cent. That's not very much. What's happening here is that there's some limit, some maximum that this approaches. And at a certain point, instead of saying we compound with greater and greater frequency, we just say that we compound continuously. So we have this formula that seemingly came out of nowhere that we use to describe interest compounded continuously. If we invest some starting amount at an interest rate R, compounded continuously, then the balance after t years is given by this expression, where this number E is something called Euler's number. I know it doesn't look like it, but that word is pronounced Euler. It's the name of a mathematician. And when you look at it, this formula is real weird. It's definitely real weird. What's going on here? The interest rate is in the exponent. How'd that happen? We'll see a little bit of how that happened in the next video. For now, let's just notice that if we use the interest compounded continuously formula for this $5,000 investment at 5% for 10 years, we get that P of 10 is 5,000 times this number E, and this is just a number, although I haven't told you what it is yet, to the interest rate is 0.05 times 10. Okay, now, all of the stuff with the hourly and so on, we could, in theory, have evaluated that by hand. Since we have not talked yet about what value that number E even represents, we can't do this one by hand, but we can do it on the calculator. So, looking carefully at this calculator, we see this little e to the x above this key that says ln on it. We'll talk about what that ln means a little bit later too. But this e to the x is the second function on this key. And when I press it, it gives me a letter E and then a place to enter an exponent. So I could enter this expression as 5,000 times e to the 0.05 times 10. So if we compound continuously, we get 8243.61, which you'll notice is 2 cents more than compounded hourly gave me. Okay, so the calculator can do this arithmetic for us, but this is a really strange formula. In the next video, we'll talk about what that number E is and some of where this strange formula comes from.